this is Joy Varghese from Uncovering Chemistry. This is video number 23, chapter Haloalkane and Haloarenes. Today we will be solving intext question 10.7, 10.8 and 10.9. Now it is given in your textbook, you can see here, page number 316. The first question is, which alkyl halide from the following pairs would you accept to react rapidly by SN2 mechanism? Explain your answer. Now in this question it is very simple. You have to identify primary, secondary and tertiary alkyl halides, right? So it will be easier for you because the order you know about SN2 mechanism. Okay. Now for solving this, pay attention. This is intext question 10.7. Here you have to identify which one will react rapidly by SN2 mechanism. So in your book, if you see here, the first one here, that is the first question in that. You can see this is bromobutane, what we say, reacts faster than this 2-bromo. 1-bromobutane will react more than 2-bromo. The reason is what? The 1-bromobutane is a primary alkyl halide, while the 2-bromobutane is what? Secondary alkyl halide. And we know the order, that is some steric hindrance in secondary alkyl halide, then in what? Primary alkyl halide. Why? Because in this case you can see the groups, only one group are there, but in this case you can see this is the group which creates the steric hindrance for the nucleophile to attack at this carbon, right? So that's why this primary one will react faster than secondary. Okay, second one, when we see here, second one, what we see here, what is written here, this secondary and this is tertiary. This carbon is your tertiary carbon and this is your secondary carbon, right? So according to the order, who will react faster? So obviously in SN2, this is what? Sorry, this is wrong here. What is written? This is secondary alkyl halide, right? Now in this case, this one will react faster than what? Tertiary, due to lesser steric hindrance, right? Why? Because in this tertiary carbon you can see there are more electron donating group. Which group? Electron donating group. So more steric hindrance. So it will be difficult for the nucleophile to attack at this carbon, right? And in this case there are only two groups are there which create this steric hindrance, obstacle what we call, right? So who is more reactive in this case? This one is more reactive, secondary than tertiary alkyl halide. Understood everyone? Secondary alkyl halide is more reactive than tertiary. So this part is clear. The third and the last one of this 10.7, what is written here? You can see here. This is the two structures what are given. Now in this case you can see Br, what is written here? You can see in this both cases, you can see the Ca3. If I number this one, 1, 2, 3 and this 4, right? So the methyl group at is which position? Third. Bromine is same in both the cases. See 1, 2, 3 and 4, right? Here the methyl group is at which position? Here second position and here third. So what are written? Both are primary halides, but the structure 2 means this structure, the CH3 group is at which carbon? Second carbon, which is closer to bromine. So this group is nearer to bromine atom, while in the first means this structure, the CH3 group is far from bromine, it is at third position. Thus the one which is far from Br, that is the group, this is which group? Electron donating group, which creates a steric hindrance, is far away from Br, right? So this will react faster than this. So this you have to remember and keep. Okay. Now the next question. Now we are going to discuss the second 10.8. In the following pair of halogen compound, which compound undergoes SN1 faster? What is the word here? SN1. So SN1 reactivity order is different than SN2 what we have discussed, right? So this you have to be very careful, right? So now we will be solving this 10.8. See now. This is your 10.8 in-text question. You can see here these structures are given, bond line structure. In the following halogen compound, which one will react SN1 reaction faster? So if you see the first, the reactivity of alkyl halide toward SN1 reaction depend upon the stability of the intermediate carbocation form. That is first step what we have discussed, formation of carbocation. And as what tertiary carbocation is greater than secondary and primary. So tertiary will react faster in this case. So when I write here, this is the carbon what we say attached to three other carbons what we say, CH3, CH3 like this, bond line what you have studied here in 11. So this carbon is attached to three carbons what we say. So this carbon is a tertiary alkyl halide what we say, and in this case this carbon attached to halogen is attached to two other carbons only. So that's why this is your secondary carbon. So tertiary is more reactive than secondary, that's why this structure is more reactive than this structure. Okay, so this one will react, since tertiary alkyl react faster than secondary alkyl halides. What is written? Due to the stability of intermediate what tertiary carbocation. This we discussed in our previous videos. Okay, so this one will react faster. Now in that only the second one what is given, you can see it clearly. Okay, what is given here? Due this one second. Now this one when I write here the carbon here, so this carbon it is attached to two others. So this carbon is tertiary, it is attached to halogen, right? And it is attached to two others. So secondary, secondary. And when we talk about in this structure, so this is the carbon to which it is being attached, right? And this carbon is attached to one only carbon. Many are there, but what we say, the one attached to halogen. Okay, so here this carbon is attached to one carbon here and one halogen. So this carbon is your primary carbon, and according to order, who will be more reactive in SN1? Secondary is more reactive than primary. Therefore this structure will react faster to SN1 mechanism. Okay, 1 minute. Now this is the last question. Identify A, B, C, D, E, R and R1, that is R dash what you can say, in the following, right? Now in this case this two will be having a problem, but in this case there is one mistake in the question, so that we will be rectifying it later. Okay, first we'll discuss about this part. See, this is your in-text question 10.9. Cyclobromine, you can see bromocyclohexane, if you remember, this is cyclic group. So you can see this reacts with what? Mg in presence of dry ether, that is Grignard reagent what you discussed. What you get? Cyclohexyl magnesium bromide, means you got what is A. This when treated with water, you will see here what will happen. This H from water will get substituted here, because in H we know there is H plus and OH minus. So this H will be substituted here, and this OH from this will react with this, and you will get what? MgOHBr. So you got cyclohexane Sb, right? So from the question you can see, question what was there? A and B is found out. Now we will find out C and D, right? So now the next part what is written here, you can see RBr, that is Rx, when treated with Mg you will get what? RMgX, that is Grignard, right? So what happens in this case, you can see easily, dry ether RMgX in presence of, here we have seen water, here it is hard water, D2O, deuterium what we said, heavy water, sorry. Okay, so in this case this H will be substituted at this position what we have talked about, right? So what was the question asked here? Question asked here, you can see here, this is the question what is asked. Actually this is not D, this is deuterium. What is it? Deuterium, isotope of hydrogen what you have discussed, right? So you can see this C when it reacts with what? D2O, what you will get? You will get this product is the question asked. Now after that E, R and all what are there? So since D gets attached to the, what is the word given? Carbon atom, same carbon atom on which what? MgBr or Br was present, so that what you will see here? RBr, that is Rx what we say here. CH3CH, CH3, or what is given, these three products can be formed, what we say, this any of these products can be formed. But the question lies here, what is the word here? Tertiary alkyl halide do not undergoes Wurtz reaction, that we have studied in the previous videos. Therefore the question is what? Not correct. They undergo, what is the word given? They undergo dehydrogenation halogenation. Dehydrohalogenation means what? Removal of hydrogen and removal of halogen, right? So to give what? Alkenes. Hence R dash C H3 tri CH, what we get, what is given here. So if I take this compound, what is this one? If you see 1, 2 and 3. So what is that? 2-methyl prop 1-ene, right? So in presence of what is given, this is the tertiary butyl what we are going to take. What is the word? Tertiary halide. So if I take this tertiary halide, it will be easier. So if I treat this with what? Na and ether, what will happen? This Br and one H from the next carbon will be removed, right? So you can see here, from here if I remove this H from here and Br from here, you will see between these two a double bond is formed. You can see here, right? So here CH3, instead of CH3, what is there? What is there? CH2 is being written. So this is dehydrohalogenation of tertiary. Now in this, if I add Mg, so actually this is what? Alkyl halide plus Mg. So what you will get? This one alkyl halide plus R, that is tertiary one, plus Mg and X. So this is the tertiary carbon which gets attached here, and this is MgX. So this is your Grignard reagent that is considered as D product. And in this, if I add water, we know in water what will be there? H plus and OH minus will be there. So this H plus will be substituted on this carbon, and this OH minus will go with this. So that is, here you can write down plus Mg OH Br. Right? So in your book, the question what is given is little bit wrong. So instead of what we say, your question what is written like this, no? This one. You have to take what? You have to take this one. Tertiary halide you need to take. Then only you will get your answer. Understood? So little bit, just go through it again. What is Wright's reaction and all. So this part will be clear to you. Okay? So this is the in-text question 10.7, 10.8 and 10.9. Next next there is no in-text question. Next exercise question will be discussing conversion and some important questions, that is conceptual base. Okay, but after to be along with this video, I will be sending the summary of this chapter. Right, so you can write it down and make a nice graphical represented diagram for understanding all the reactions and all. Okay, I'll stop here. The last question in this explanation, I think most of you will be having problem in this part what we discuss here, right? So we will be discussing this later when we will meet in school, or if any queries are there related to this, you can ask. I will explain it again. So what I explained in this video, please go through it, rewind it, pause it, understand Wright's what is there, understand tertiary halides why doesn't give Wright's reaction and all, and then only you will understand this last part of the question. This truth I think it is clear to you. Only this part you will have little bit problem, right? Understood or not? Means Rx what you R1 or R dash X what must be taken this R to get these two reactions, right? Then only it will be clear. This is Wright's reaction what we are talking about, Wright's. Right, now Wright's I think you must be knowing that what Rx plus Rx plus 2Na plus Rx. You remember we have written like this and we removed like this. Sorry, X 2NaX was being removed. So R and R we got. So instead of this, if I use R dash, no, these two R dash will get combined. This is one R dash and this is another R dash. Okay, so you can see here R dash will combine with each other plus Na, 2Na, X is being separated, right? So I am giving one hint again. So what you have to do, be careful. Okay, and in this case what we say here, Mg and dry ether will come, dry ether, that is for Rx and Mg. So RMgX means this one will be your Grignard reagent. Which reagent? Grignard reagent. Okay, and that you treat it with water, you will get the alkane what we say. Understood? So go through this again. Reaction with metal, what we have discussed now, in that Grignard we have discussed. So this part will be clear to you. Okay, I will be stopping here this chapter. Next time we will consider doing with the exercise questions. Okay, bye.